Now, according to question, first I'll read the question. In GATE 2021, in the circuit switch S is closed position for a long time. If S is open at t is equal to 0, then ILT in ampere for t is greater than 0. Our motto: determine current in inductor at t is greater than equal to 0. So how can we determine? First of all, it is based on switch based question. Okay, you can resolve this question two types. First one with the help of Laplace, and second one with the help of formula. Okay, formula is valid, I know that. Which formula you use here? That is ILT. ILT is equal to IL infinitive plus IL minus 0 IL infinitive into e to power t by tau. And what about tau? Tau is equal to L divided by RTH. Okay, this formula is valid only for independent source, not time variant field, not for AC and not for time dependent, like if voltage 10 t corresponding. Okay, this formula is valid only for DC. Okay, if this formula is applied, then condition is also. Otherwise, with the help of, you can resolve with the help of Laplace. Okay, so our motto: determine IL infinitive, IL 0 minus and tau. Okay, so how can we determine? There are three circuits possible. L infinitive, t tends to, you can say that first of all determine this one, t less than 0. T less than 0 means at steady state. What about switch? Switch is closed. That time inductor behave as a short circuit. At steady state, inductor behave as a short circuit. Okay, so first of all make the circuit. If this one is closed, it means circuit look like simply plus minus 10 volt, here 1 ohm, 4 ohm, and that 30 volt, and that is IL infinitive, sorry, IL 0 minus. Okay, so IL 0 minus is, apply KVL, minus 10 divided by 1, 10 divided by 1, that is 10 ampere. Clear? Now t greater than or you can say t tends to infinity at steady state. What about switch? That time is open, switch is open. What about inductor? Inductor behaves as a short circuit again. That time circuit simply plus minus, and this is open, and that is 4 ohm, and this one is 30 volt, and this one is 1 ohm, and inductor behave as a short circuit. Okay, minus to plus, minus 10 volt plus 4 IL infinitive minus 30 plus 1 into IL infinitive, this is equal to 0. So IL infinitive, this is equal to 40 divided by 5, that is 8 ampere. Okay, now next one, t is greater than 0. Our next target is determine RTH. So if you determine RTH corresponding to this inductor, then inductor is behave at that time open, and all independent source reduced to be 0. Voltage, if voltage is available, then voltage behave as short circuit, and if current is available, current and voltage both are independent. If both are independent, then this is equal to 0. Okay, that is independent. So, and this one is also independent, that both are short circuit. Okay, reduced voltage is 0 means that is behave as a short circuit. Clear? I have already discussed in theory. And what about switch? That time that is open because t is greater than 0. Same condition. only 4 ohm resistance here, and this is short circuit, and only 1 ohm resistance, and here that is RTH, that is 1 ohm. And so what about RTH? RTH is, both are series, so 5 ohm. If these value put here, ILT, what about ILT? IL infinitive, that is 8, and here 10 minus 8 into e to power t by tau. Tau is, L is 0.5, and that is 5, that is 0.1. So 0.1, or you can say that 8 plus 2 into e to power minus 10t. Clear or not? This is the final answer. Very simple. According to question, in the circuit switch S is closed position for a long time, if S is open at t this is equal to 0, if t is equal to 0, this is open, then our motor determine current in the circuit. So how can we determine? First of all, determine IL, be using formula this, because if this formula is valid only for DC network, okay, not in AC or time dependent. Okay, so clear. Now our independent source also, if dependent source also available, then this formula is not applied. So clear. So IL infinitive and IL 0 and our motto RTH. So how can we determine these parameters? T less than 0, steady state. At steady state, switch is closed, switch S is closed, that time inductor behave as short circuit. So make the circuit, switch is closed, and make the circuit determine IL, that is 10 ampere. After t tends to infinity, at a steady state switch S is open, L behave as a short circuit. Clear? That time circuit determine current like this one. After that, next target is RTH. If you determine RTH, that time independent source behave as a source, reduced to be 0. If voltages are available, independent voltage are available, the voltage behave as a short circuit, and if current is available, then current is behave as an open circuit. So make the circuit and determine RTH, and then tau is equal to RTH L divided by RTH. So this value like this one. After find these parameters, this one and this one, put in this equation and find the answer. 8 plus 2 into e to power minus 10t ampere. This is the final answer. Make it.